Good evening, friends. Today, let's discuss the concepts of polynomial equations, under which quadratic equations is the concept I am going to take it up with you. This is one of the very elegant chapters, I can say. Friends, why I say elegance is, we have learned this from the 6th standard. Concept of linear, quadratic, biquadratic, all that. And this quadratic concept is taken into various areas of other branches of mathematics. You name the area, I will show you the existence of linear and quadratic polynomial equations. And number 2, this heads a branch called algebra. In fact, algebra has come out of this. We have branches like arithmetic, algebra, geometry and all that. This purely goes into that. If I say in the language of computers, this talks like a software. So we will be enjoying this for next 1 hour. I, Dr. Manjunath, welcome you all to this YouTube session of polynomial equations or quadratic equations. Friends, this is a specific YouTube classes through Unacademy. By now you must have enjoyed these classes, and Unacademy is doing a beautiful and wonderful work by bringing in the best of best educators across the country and making them to reach you people through this virtual platform. I know we are all running through a very bad time, but thanks to a group like Unacademy, which is helping people like you to not forego any of the benefits that you have to get during your crucial year called 11th and 12th standards, which are your life deciding years. And it has taken all the measures. Bit by bit, Unacademy is working on educators, encouraging them, helping the students, setting up of a beautiful platform through this virtual technology. And we reach your doorsteps, we reach your homes, we reach your desks and give you the concepts. Friends, my earnest request is make use of this. If you have not subscribed to this channel till now, please subscribe it. Like the button, press the like button, subscribe the channel and utilize this to the extent that you need. There are many video lessons like this on the YouTube. Please make sure that you take the benefit of it to the maximum extent. So welcome you all once again to this YouTube live session on quadratic equation. This is Manjunath. A linear equation in X is an equation of the form ax plus b equal to 0, where a is not equal to 0. The only root of this equation is given by x equals minus b by a. A quadratic equation in X is an equation of the form ax plus bx plus ax square plus bx plus c equal to 0. And please understand where a is not equal to 0. it has two roots. The equation f of x is equal to a0 into x power n plus a1 into x power n minus 1 plus up to the values of an minus 1 into x plus an equal to 0, where n belongs to natural numbers and a naught is not equal to 0, is called a polynomial equation of the degree n, and it has n roots which are real or imaginary. So this tells us very clearly a polynomial equation means it's an equation which has got n roots which are real or imaginary. If f of x is equal to 0 is of odd degree, then it has at least one real root. If f dash of x is greater than 0 for all values of x, then the equation f of x is equal to 0 has at most one real root. Friends, I have a question to you. Please answer me. You can see the solution, you can see the answer on the screen, but still I want you to answer me this question. There is an equation in front of you, polynomial. The number of real roots of the equation is x power 7 plus 14x power 5 plus 16x cube plus 30x minus 560 equal to 0. Just think, whatever that you have understood as on today about it, give me your answer. Many people may go with the concept of 7 because x to the power 7 is the highest value, and sir, you are talking till now x power n means there are n roots. So let me say the real roots are n, 7. It's wrong. F dash of x is equal to 7 x power 6. I am differentiating this. You know that x power n, if you differentiate, it is going to be n into x power n minus 1. Am I right? So if I differentiate this, 7x power 6 plus 70x power 4 plus 48x square plus 30 greater than 0 for all values of x, therefore f of x is equal to 0 has at most one real root. An odd degree equation has at least one real root. There are two sentences that has been used to you. After differentiating this for all values of x, f of x is equal to 0 and it has got at most one real root. At most, maximum to the almost, if I can say, it can have one real root. And an odd degree equation has at least one real root. These two are the important terms, though there is a small variation in the language here, but still it means a lot. When it is even, it has at most one real root. When an odd degree equation exists like this, it has at least one real root. Therefore, f of x is equal to 0 has only one real root. See, the option is 1. If f of a and f of b are of opposite signs, then the polynomial equation f of x equal to 0 has at least one real root between a and b. If f of a and f of b are of opposite signs, f of a and f of b are of opposite signs, then the polynomial equation f of x is equal to 0 has at least one real root between a and b. Next, friends, one more sum I would like to discuss. If a less than b less than c less than d, determine whether the roots of the equation x minus a x minus c plus 2 into x minus b into x minus d equal to 0 are real and distinct or not. Okay, f of a equals 0, a minus a is 0, so this first value becomes 0, plus 2 into a minus b into a minus d. As the value is 2 into this, definitely it is greater than 0. Put c in this equation and see f of c value you can find out. Again this becomes 0, the first value, c minus c becomes 0. So these two gets into 0 value. 2 into c minus b into c minus d. C minus b. C is greater than b. C is less than d. This is plus 1. This is minus 1. Here both were small. So minus 1 into minus 1 would have been plus 1. Into 2 is 2, which is greater than 0. Here it is 1, here it is minus 1. So minus 1 into 2 is minus 2, which is less than 0. Friends, these two terms are very important. So f of a and f of c are of opposite signs. If this is positive value, this is negative value. What is said here? If they have opposite signs, then the polynomial equation x is equal to f of x is equal to 0 has at least one real root between a and b. So therefore, there is a one real root between a and c, and the roots are real and distinct. The roots are real and distinct. These questions, when it comes in the competitive examination, you need only the fundamentals. See, fourth rule, if it is remembered, you can answer. In this, if you remember first, second, third rules, you can answer it. So you need to have the basics to answer them in a perfect manner. Fifth rule. If alpha is a root of f of x, which is equal to 0, then minus alpha is the root of f of minus x, which is equal to 0, and alpha not equal to 0. 1 by alpha is a root of f of 1 by x, which is equal to 0, and k alpha is a root of f of k x by k, which is equal to 0. See this. If alpha is a root of f of x equal to 0, then minus alpha is a root of f of minus x equal to 0, and alpha not equal to 0, that is 1 by alpha is a root of f of 1 by x equal to 0. Finally, k alpha is the root of f of x by k equal to 0. 1, 2, 3 and 4. 4 concepts are being discussed here. Alpha is a root of f of x equal to 0. Then minus alpha is f of minus x equal to 0. Alpha not equal to 0 means 1 by alpha is a root of f of 1 by x. Then k into alpha is a root of f of x by k equal to 0. You have a sum here. Please look into this and let me know the answer. Alpha and beta are the roots of the equation 9x square plus 6x plus 1 equal to 0. Then the equation with roots 1 by alpha and 1 by beta is. See here the condition is f of 1 by x is equal to 0. So how it becomes? It is 9 into 1 by x square plus 6 into 1 by x plus 1 equal to 0. Multiply the whole equation by x square, 9 plus 6x plus x square equal to 0. This is the equation. X square plus 6x plus 9. So third option is the right answer. Alpha and beta are the roots of this equation, and if these roots become 1 by alpha and 1 by beta, then give the equation for us. If x becomes 1 by alpha becomes 1 by alpha, x becomes 1 by x. So it is 1 by x square plus 1 by x plus 1. This equation got changed like that. Then we multiplied with x square so as to bring it into the standard form. X square plus 6x plus 9 is the standard form. So that's the answer. Sixth point. If all coefficients are positive, then the equation cannot have a positive root. If all coefficients are positive, then the equation cannot have a positive root. There is an example there. 4x square plus 7x plus 2 equal to 0 cannot have positive roots. It can never have, I can say that. 4x square plus 7x plus 2 can never have. Since all the values are positive, it can never have positive roots. See, for example, I can factorize this and show you. 4x square plus 7x plus 2, correct? All of you have learned this factorization in your smaller classes. 4x square Say 4 2s are 8. So you need to get 7 here. Multiplied value will give you 8x. See, when you multiply it is 8x square, and when you add it you should get 7x. How you will get? Seven x. Say 4x into 2x is 8x square, correct? But 4 plus 2 will be 7. 7 into 1 is, it is 8x into 1 is 8x. But you have to do it like this. 8x into 1x is 8x, 8x square, and 8x minus x will be 7x. 4x you take out common, x plus 2 minus 1 if you take out common. Yes. See, still it is not matching. See, this is the reason they said you can't have positive roots in it. And this kind of sum you can easily solve it using formula minus b plus or minus root of b square minus 4ac by 2a. If you apply, you can factorize that. So you can never have, if there is a positive value in the whole equation, you can never get positive roots. Next point, if the coefficients of f of x is equal to 0 are rational, then irrational roots occur in conjugate pairs. Coefficients of f of x is equal to 0 are rational values, then the irrational roots occur in conjugate pairs. 2 plus root 3, 2 minus root 3. If 2 plus root 3 is one root, then the other root is 2 minus root 3. Then only you can have the coefficients of f of x can be 0. Both the ways it can say it. If the coefficients of f of x is equal to 0 are rational, then irrational roots occur in conjugate pairs. If irrational roots occur in conjugate pairs, then the coefficients of f of x is always 0, which are going to be rational values. If the coefficients of, next point, if the coefficients of f of x are real, then the imaginary roots occur in conjugate pairs. If the coefficients of f of x is equal to 0 are real, friends, these terms are very, very important to you. If they are real, then the imaginary roots occur in conjugate pairs. Example, you can see it here. If 2 plus I root 3 is a root of x square plus px plus q equal to 0, where p and q are real, then p comma q is how much? 2 plus I root 3 is a root of x square plus px plus 0, q equals 0. Friends, one small correction in this. 2 plus I root 3 into plus 2 minus I root 3. Same way here, 2 plus I root 3 into 2 minus I root 3. sum of the roots is actually minus b by a. You will be seeing all these things little later. I'm just giving you randomly concepts. So if I add these two things, plus I root 3 minus I root 3 cancels. 2 plus 2 is equal to 4, which is equal to minus b. So therefore, what is p equals? Minus 4. Similarly, when you take the product of these two, it is 2 whole square minus I root 3 the whole square. 2 square is 4 minus I square is minus 1. I is root of minus 1, correct? I square will be, this is going to be I square into root 3 whole square is 3. This is minus 1 into 3. Minus 1 into 3 is plus 1 plus root 3. Sorry, plus 3. 4 plus 3 will be equal to 7. That is what is. So P is minus 4 and Q is 7. Minus 4 and 7. We have second as the option. Friends, you must know these contents very well. If we know this, then we can able to do it. What they say? If coefficients of f of x is equal to 0 are real, see, coefficients of f of x, here they are real. P is real, x square coefficient is real. If they are real, then the imaginary roots will be there as the conjugate pairs. Conjugate pair means 2 plus I root 3, 2 minus I root 3. That conjugate to each other. So we got the answers here. What is P and Q value? We could able to get out of it. Next concept, remainder theorem and factor theorem. One of the very important content of quadratic equation. Probably I can say this is a base. This remainder theorem and factor theorem, if it is known perfectly, that means it lays a good foundation for your learning of quadratic equation. Let's take it. When x minus a divides f of x, the remainder is f of a. And if f of a is equal to 0, x minus a is a factor of f of x. When x minus a divides f of x, the remainder is f of a. And if f of a is equal to 0, x minus a is a factor of f of x. Let's consider f of x is equal to x power 4 minus 2x cube plus 2x square minus 7x plus 6. Then, if you take when f x plus 1 divides f of x, x plus 1 divides f of x, then the remainder is f of minus 1. Then the remainder is f of minus 1. So substitute minus 1 into this equation and see. Minus 1 to the power 4 is 1. Minus 1 whole cube is minus 1 into minus 2 is plus 2. Minus 1 whole square is 1. 1 into 2 is 2. Minus 1 into minus 7 plus 6. 7 plus 6, 13, 15, 8, 17 plus 1, 18. When x plus 1 divides f of x, the remainder is minus 1 f of 9. Similarly, when x minus 1 divides f of x, the remainder is f of 1. So 1 power 4 is 1. 1 into 1 cube is 1, 1 into minus 2 is minus 2, 1 into 2 is 2, 1 into minus 7, 7, minus 7 plus 6. 6 plus 2, 8, 8 minus 7 is 1, 1 plus 1, 2, 2 minus 2 is 0. Hence, x minus 1 is a factor of f of x and 1 is a root of the equation f of x equal to 0. Next, if sum of the coefficients in f of x is 0, then x equal to 1 is a root of f of x equal to 0. If the sum of the coefficients in f of x is 0, sum of the coefficients in f of x is 0, then x equal to 1 is a root of f of x equal to 0. Simple terms, but very important to be remembered. If you add the coefficients of f of x and if you get that sum as 0, then x is equal to 1 is a root of f of x which is equal to 0. If sum of the coefficients of the even powers of x is equal to sum of the coefficients of the odd powers of x, then x equal to minus 1 is a root of the equation f of x equal to 0. I'll take an example to describe this. X is equal to 1 is a roots of the equation a minus b into x square plus b minus c into x plus c minus a equal to 0. Because summation of a minus b is 0. Consider the biquadratic equation x power 4 minus 2x cube plus 2x square minus 7x plus 6 equal to 0. The sum of the coefficients is 1 minus 2 plus 2 minus 7 plus 6. Minus 7 minus 2 is minus 9. Plus 6 plus 2 is 8 plus 1 is 9. Minus 9 plus 9 is 0. Hence, x equal to 1 is a root. Sum of the coefficients of even powers of x. Even is 4, 2, these things if you take 4, 2 and this is 0. 1 plus 2 plus 6, it is 9. Sum of the coefficients of the odd powers, this and this. Minus 2, minus 7, which is minus 9, and they are not equal at all. This is plus 9, this is minus 9, they are not equal. Hence, x minus 1 is not a root. X equal to minus 1 is not a root. This example, you must get it perfectly into your minds. You can take time. There is no need of hurrying up, friends. But when you are assimilating it, when you are taking it for the first time, if the concept is very clear, I will tell you, you will not forget it. Yx is equal to 1 is a root and yx equal to minus 1 is not a root. And how? You have seen that here. They have added all the coefficients of the even values. They have added all the coefficients of the odd values. And if they were equal, then you could have said x equal to minus 1 is a root. But since they are not equal, x equal to minus 1 is not a root. And how did you prove x equal to 1 is a root? They took all the coefficients, they added it up, and its value came out to be 0. And you can directly say that x is equal to 1 is a root. See here, x power 4, 1. X cube is 1 into minus 2, minus 2. X square is 1, 1 into 2 is 2. X into minus 7, that is 1 into minus 7 is minus 7 plus 6. When x you put it as 1, you get that coefficients as it is, and when you summated it, when you got it as equal to 0, that means that is a root of it. But when you took x equal to minus 1, then they gave you the condition like add all the even powers, add all the odd powers coefficients, then summate it, you should get the answer as same. But we got the answer same but with different signs. Plus 9 and minus 9, there is a huge difference. They are not equal at all. Therefore, x of equal to minus 1 is not a root at all. There is one interesting division, friend, called synthetic division. This is to find the remainder and quotient when a polynomial is divided by x minus a. We have a method known as synthetic division. This division, what you are seeing below, is called synthetic division, which is illustrated with an example. There is something called x power 4 minus x cube minus 3x square plus 4x minus 4 equal to 0. And we need to check whether 2 is a root of this or not. See, first, in the first row, they wrote all the coefficients. X power 4 coefficient is 1, x cube coefficient is minus 1, x square coefficient minus 3, x coefficient 4, constant minus 4. Then they took one third column, 1 here, the same one that was taken here, and whatever the root value they have considered, they started multiplying with it. 2 into 1 is 2, 2 minus 1 is 1, 2 into 1 is 2, minus 3 plus 2 is minus 1, 2 into minus 1 is minus 2, 4 minus 2 is 2, 2 into 2 is 4, 4 minus 4 is 0. If you get the total as 0, then f of 2 is a root of this equation. If f of 2 is equal to 0, that means that's the root of the equation. See the way they have calculated. This is called synthetic division. They wrote all the coefficients first and the same number is brought down, and with whatever the root word they have said, they started taking it and multiplying it, and they got the answers. One of the beautiful methods, very interesting thing to know about. That's why I always say maths is a fun learning subject. You can do, see, this is like a game. You can play with it. You can write n number of equations like this and start checking whether it is a root or not a root. If you don't get it as equal to 0 here, if you get some other value, then it is not. If in place of 0, if you get 5, 6, 7, 3, anything like that, then f of 2 is not a root of this equation. You should not get a remainder. The remainder need to be 0. That's why it is called remainder and quotient usage in the polynomial system. The method is called synthetic division. Friends, now we have few relations between the roots and coefficients. If alpha and beta are the roots of the quadratic equation ax square plus bx plus c equal to 0, summation of the roots is minus b by a. Big punchline of this equation, quadratic equation. First and foremost, and this is used everywhere across the chapter. If ax square plus bx plus c equal to 0 has two roots alpha and beta, summation of the roots is always minus b by a. I had already applied this in one of the examples there. And product of the roots is c by a. If I summate the roots, it is minus b by a. If I take the product of it, it is c by a. One of the fundamental equations which we should not forget. Number 2. If there are three roots, alpha, beta, gamma, if it is a three-root equation, it's always called cubic equation. Two roots, quadratic. Four roots by quadratic. So, three roots, alpha, beta, gamma, equation is ax cube plus bx square plus cx plus d equal to 0. Then its summation, that is alpha plus beta plus gamma. The summation is minus b by a. One minus is missing in this. Minus b by a. Then summation of alpha beta plus beta gamma plus gamma alpha. Summation of two terminologies. Summation alpha beta plus beta gamma plus gamma alpha is c by a. Two roots are multiplied and they are added in the cyclic order. Alpha beta, beta gamma, gamma alpha, their summation is c by a. And last, product of alpha, beta, gamma is minus d by a. See, we got fourth because there was a fourth term also in this. Minus b by a, c by a, minus d by a. Three terms. In quadratic, we had only two terms. Here, three terms. Now, by quadratic, alpha, beta, gamma, delta are the roots of biquadratic equation. Ax power 4 plus bx cube plus cx square plus dx plus e equal to 0. Then summation alpha equals minus b by a, summation alpha beta equals c by a, summation alpha beta gamma is minus d by a, alpha beta gamma delta is e by a. Fourth term got added. Cubic, we had three equations, quadratic 2 and now biquadratic 4. Summation of all four, alpha, beta, gamma, delta. When you add all the four, it is minus b by a, alpha, beta, beta, gamma, gamma, delta, delta, alpha. If its summation is c by a, three terms now. Alpha, beta, gamma, delta, gamma, delta, alpha, gamma, delta, alpha, yeah, beta, gamma, delta. These summations is minus d by a. And lastly, all the four, product of all the four roots is e by a. But one thing you should take into consideration, similarities. Summation of single roots is minus b by a, minus b by a, minus b by a. Then product of two. See, this had only 2, so you got c by a. Here two products and their summation c by a. Here also c by a. And now connection between these two. Product of 3 and its summation minus d by a. And last all. If you compare like this and remember, you will not make mistakes. Summation of the roots and product of the roots. So friends, point 1, point 2 and point 3. I would request you all repeat it today m number of times. You teach this to your parents, you teach this to your grandparents, teach this to your pets so that it gets into your mind and it gets fixed up. Once this fixes up properly, you can play with quadratic equation. These three are the basic punchlines. The way I said factor theorem is one of the strong bases. On that you have already started building the things using these. So relation between the roots, if it is known, anything can be done with this. Fourth point, symmetric function of the roots. Any expression containing the roots of a polynomial equation which remains unchanged when roots are changed in the cyclic order is called symmetric function of the roots. If the roots remains unchanged, when the roots are changed in the cyclic order, the expression should not change. The expression containing the roots of a polynomial equation remains unchanged when the roots are changed in the cyclic order, and it is called symmetric equation. Example you can see here, alpha by beta plus beta by alpha is a symmetric function of the roots for a quadratic equation ax square plus bx plus equal to alpha square plus beta square by alpha beta. This will be alpha square plus beta square by alpha beta. Second one, alpha square plus beta square plus gamma square is a symmetric function for a cubic equation. Alpha square plus beta square plus gamma square is a symmetric function for a cubic equation. Then one important formula that you should remember, very very important, and this is very essential equation. Summation alpha square. Summation alpha square is alpha square plus beta square plus gamma square. This one. This is called summation alpha square. It is equal to summation of alpha whole square. Summation of alpha is this. Alpha plus beta plus gamma, or alpha plus beta, or alpha plus beta plus gamma plus delta. This is only cubic equation, so we are taking only alpha, beta, gamma values. So summation alpha square in this is equal to summation alpha the whole square plus 2 summation alpha beta. That means alpha beta plus beta gamma plus gamma alpha. Do you remember this? Summation alpha the whole square is alpha square plus beta square plus gamma square equal to summation alpha whole square alpha plus beta plus gamma minus 2 into alpha beta, beta gamma plus gamma alpha. This is what it is. Oh, sorry, here it is square. Anything that strikes here, friends, to you? Can I remember like this? A square plus b square is equal to a plus b the whole square minus 2ab. Does it resemble that? Yes, exactly. Let's take some examples to study this. in a proper manner. Alpha, beta, gamma are the roots of x cube minus 4x plus 2 equal to 0. X cube minus 4x plus 2 equal to 0. Now we need to find summation of the roots. What is summation of the roots? Minus b by a. Minus, see this is x cube, x square value is 0, that's why it is missing. Then 4 minus 4x plus 2 equal to 0. B is 0 in this. So 0 by anything is 0. And summation of alpha beta, product of 2, it is c by a. Minus 4 by 1 is minus 4. And alpha beta gamma, product of all the 3 roots, it is d by a, minus d by a. So it is minus 2 by 1, which is minus 2. Summation of roots 0, summation of product of 2 roots and its summation is minus 4, and product of all 3 roots is minus 2. Now you need to find then their summation, alpha square plus beta square plus gamma square. Just now what you did, summation alpha square is equal to summation alpha the whole square minus 2 summation alpha beta. Okay, summation alpha square is equal to alpha the whole square, this is 0 whole square minus 2 into summation of alpha beta minus 4. Minus 4 into minus 2 is 8. That's the answer. Then if you have to calculate alpha cube plus beta cube plus gamma cube equals, and you know that it is nothing but equal to 3 alpha beta. If alpha plus beta plus gamma equal to whole square, sorry, alpha beta gamma is equal to 0, a plus b plus c is equal to 0, what is a cube plus b cube? That will be 3ab or 3abc, like that. That's the same concept that need to be applied here. So alpha cube plus beta cube plus gamma cube is equal to 3 times alpha beta gamma. So 3 into what is alpha beta gamma value? Minus 2 plus minus 6. If sum of these 3 values are equal to 0. We have done this in primary high schools and all. If a plus b equal to 0, or a plus b plus c equal to 0, then what is it? 2 plus b cube? This is equal to 3a. And if this 3 values, then it will be c cube equal to 3a. We have done plenty of this kind of sums. The same thing, I am just repeating. Then alpha, beta, gamma are the roots of x cube minus 2x plus 1 equal to 0. Find the value of summation 1 by alpha plus beta minus gamma is. This is another cubic equation they have given. You need to find the value of 1 by alpha plus beta minus gamma. You have to be very careful with this. When a cubic equation is given like this, and if the b term is missing in this, a is there, b is missing, c is there, d is there. B is missing means summation of the roots will be 0, and summation of product of 2 roots into its summation. Summation alpha beta is equal to, it is c by a, that is minus 2 by 1 minus 2. And product of all the 3 roots, it is d by a minus d by a. So it is minus 1 into 1 by 1 is minus 1. 3 values are 1. Let's take this 1 by alpha plus beta minus gamma. This cannot be written directly like that. So what they did, they added 1 plus alpha, subtracted 1 alpha. See, alpha, beta minus gamma is there. Add 1 alpha and remove 1 alpha. Now what happens? Alpha plus beta plus gamma. If you actually remove, this is the same equation. Now minus gamma minus 2. That's what you have. Alpha plus beta plus gamma minus 2 gamma. But you know that this value is 0. So it is 0 minus 2 gamma. So what do you get this answer as? It is summation minus is here. Summation 2 gamma. Correct. That means summation of 1 by 2, if you also take minus 1 by 2, if you take out summation of 1 by gamma. 1 by gamma, how do you write it? Minus 1 by 2 into 1 by alpha plus 1 by beta. 1 by gamma. Sorry. Alpha, beta, gamma. If you remove alpha, it is beta, gamma. Gamma alpha plus alpha, beta. So summation alpha, beta by alpha, beta, gamma. This is into minus half is here. So minus half into summation of alpha, beta. It is summation of alpha, beta is minus 2. And alpha, beta, gamma is minus. See these two. If you remove it, 2 also cancels. The answer is minus 1. Is this concept clear to you? See friends, this kind of sums are very, very essential to us. But you should be quick enough in solving this. I took some time because for the first time all of you are seeing this. The first 3 values you should get it by eyesight. B is missing, summation of this definitely 0 because minus B by A. C by A I need it as minus 2 by 1. I don't write all this. Just write summation alpha beta 2 to C by A minus C by A. Why it is minus here? Because C is minus 2 here. Otherwise it is C by A. And the last one, so product of all the 3 roots, it is minus D by A. So it is minus 1. 0, minus 2, minus 1. We got it. Now this arrangement alpha plus beta minus gamma. Alpha plus beta minus gamma was added with an alpha and added with a gamma, subtracted with a gamma. If these two you remove, you get the primary equation only. But we did this just for our calculation support. Now take summation of all the 3 positive roots and add up these 2 negative values minus gamma. Now what happened? It became 1 divided by 0 minus gamma to gamma, because alpha plus beta plus gamma is 0. 0 minus 2 gamma. So it is minus 1 by 2 into 1 by gamma. 1 by gamma can be said as 1 by alpha plus 1 by beta plus 1 by gamma. Take the LCM alpha beta gamma. So you get beta gamma plus gamma alpha plus alpha beta. So summation of 2 roots. So what is summation of 2 roots? It is minus 2. And what is product of 3 roots? It is minus 1. So you have minus 1 by 2 which is outside into minus 2 by minus 1. So 2 cancels, the remaining answer is minus 1. So minus 1 is the option. Friends, maths is a subject that need to be enjoyed. Maths is a concept that you need to understand, assimilate and play with. Until and unless you go deep into it, you can't get an answer out of it. I'll give you a simple example for that. See, in this illustration, there are 3 roots. Alpha, beta, gamma are the roots of this equation. What is missing in this? X square is missing, correct? So, summation of the individual roots minus b by a is always 0, correct? Then summation of two roots is, it is c by a, it is p. Product of all 3 roots is minus q. Minus of minus q becomes plus q. Did this much clear to you? That means summation of alpha is 0. Summation alpha beta is p. Summation alpha beta, no, it's not summation, alpha beta gamma. This is equal to minus d, minus of minus, which is q. First sum, alpha cube, beta cube plus gamma cube. If alpha plus beta plus gamma is equal to 0, what is this equal to? 3 alpha beta gamma. 3 into alpha beta gamma is cube. It is minus 3. Correct? Alpha cube plus beta cube plus gamma cube is equal to minus 3abc. Next, 1 plus alpha, 1 plus beta, 1 plus gamma. We need to add it up. When you do this, product of all the 3 values you get 1 plus p is this minus q. Or you don't get in this, it is minus q. 1 plus p minus q is the answer for the summation. Third, if you do this, you have already seen this answer here. Minus 1 by 2 into minus 1 you should get it, correct? It is minus 1 by 2 into q minus q. The summation I am talking about. This is going to be equal to it's actually p minus, you get p, and product is minus q. Minus of minus, it becomes plus q actually. So minus half p by q. This is the answer. See, this, if it is known to us very well, I think nobody can stop us. Friends, that's it for the day. Hope you must have enjoyed these classes very well. I request you to watch our YouTube videos. Unacademy has done plenty of such videos through many educators. And if you like this, what I have taught you, just press like button and subscribe to this. This is Manjunath signing off. I'll come back to you with one more class, with one more live demonstration on a different topic. Until then, goodbye. Take care of yourself. Have a healthy and prosperous life. Thank you very much.